Thank you so much for being here, y'all, especially you online as well. Thank you so much for being here. I know we had already, it looks like we have a great turnout virtually. We have a great turnout in person. If you are in the Dallas area, come to these events. The room is kind of packed at the moment. We have some great tables. Halfway. I'm not going to embellish too much. Half the room is full right now, but we honestly have some great developers here. We have some great people of all skill levels at this moment in the room. We have some hiring managers in the room. So thank you so much for coming out as well. Super excited for y'all to be a part of this. If you're in the room virtually, share your socials. We're going to be doing the exact same thing in person. Connect with people. Give them a reason to connect as well. If you find a great topic being shared, add some contributions to it in the chat. We're going to be monitoring the chat. Maybe there's going to be some great messages that we see as well. So we may end up sharing that with the room. So make sure you're sharing that value in there. But one big thing that I want to really emphasize here is this is like our first big event that we've done since the new year started. So thank you so much for being a part of this. Really excited for this. We have some big plans that we have coming up for this year. So I kind of want to go over a couple of things to kind of let you know what we're planning on and actually going to end up doing. But before we start that, I want to give a couple shout outs. Tonight could only be possible for three things. Number one, we have two amazing sponsors that are with us here. Number one is Vaco. If y'all know me, you know I'm a fan of Vaco. We talk about Vaco very often because I'm very particular on organizations that we partner with, Vaco being one of them. They've been a partner of mine for several years at this point. And when I came to Dallas, one of the first groups that I ended up speaking with was Vaco because they actually care about the developers in the community. They were kind enough to actually send us a dedicated rep today. So Eric over there with his hand up over there, if you have any questions at all, absolutely. If you have any questions at all, whether it's you're trying to be more marketable in this market, number one, especially who else is going to know better than someone like him, but also if you have questions, if you're even looking for a new job, that could definitely be a connection that you want to make at the end of the day. Definitely look forward to you guys having those conversations at the end of this talk tonight. He'll be there for the duration of this event. So if you have any questions or just want to exchange socials, highly recommend doing that and taking that initiative. The other sponsor that we have tonight, Yum Brands. For those that may not know, Yum Brands is the parent company of some of our favorite companies, Pizza Hut, Taco Bell, KFC, Habit Burger, just to name a few. They donated the space that we're in today. They're making a lot of these events possible. So thank you. Huge shout out to Yum Brands as well. The other thing that I want to give a huge shout out to, I'm not a one-person team. It's a whole organization that we're working together, all completely volunteer focused. We're here just to try and help out as many people as we can. We have amazing people, even from our group tonight. We have Eric over here. We have Michelle here, dedicating their time out of their busy schedules to be here. We've worked and we will continue to work on a lot more events coming soon. The other thing I want to shout out, we've had a lot of communication about this over the last few weeks. And we kind of teased that we would announce this. If you're in the Discord, by the way, if you live in the Texas area, you should be in our Discord. If you're outside of Texas, virtual attendees, you know, it may not be as fruitful for you. But locally, we have a very active Discord. And one thing that we said that we were going to announce is our cohorts. We've done 6 cohorts in the past where we basically pair developers of similar skill sets together to create projects and work together as a team with the guidance of a professional developer guiding. It is completely free. We do this just to help folks out. We do say if you want to be a part of this, I know we're getting a lot of requests, especially since we just announced it in Discord, but now letting everybody know it's going to probably increase a little bit. We're trying to figure out how we can scale this to a bigger number. We may not be there just yet, but if you do apply, we can try our best to get you in the cohort. If you don't get it this time around, there's always cohort number 8. We're trying to do these every 2 or 3 months, give or take, but the cohorts generally last 6 to 8 weeks, where it's a commitment of jumping on calls with your cohort members. You're gonna jump on a call once a week at the very least to kind of pair program with others. So it's a great skill setting. We actually have somebody here that was in the last cohort, if not more people. I do recognize one person, but we have people front and back end, mobile development, et cetera. So whatever it is that you find your skill set in, we could probably find a match or a fit. Just something to keep in mind of. If you are interested in that and you are in the Texas area, check out the Discord. We can kind of get the applications going there. And I'll share a link to the applications in the chat as well once I get back from being on stage. So huge shout out for that. The sign-ups for that, by the way, ends tomorrow. So if that's something you're interested in, highly recommend doing that. But just make sure if you are signing up, understand you could be potentially taking somebody else's spot as well. So just make sure you're willing to make that commitment for that 6 weeks. because we're going to dedicate all of our time to help you out in that process as well. With that being said, I've run my mouth good enough right now. We should get some talks going on. So we're going to open the stage up to our very first speaker. We're going to let him completely kick things off, really get things going. We have David Perry. He's the director of all the software architects at LexiPool. Give it up for David, please.
That's what companies give as titles. So thank you so much for joining tonight. And what we're going to get to is jump into is first, I'll just introduce myself as you do. I love the code. So yeah, I'm an architect and everything else, but I write code. So that's what I've been doing my whole life. I'm a Spring certified professional. I'm also a AWS solution architect professional. I'm also Oracle certified specialist in a numerous different ones, but mainly into Java. And I actually have my old Sun certification too with Java. I'm gonna first get set with, does anyone know about Chuck? We're in Texas, Chuck Norris. Okay, so Chuck Norris has a website, an API. So everyone knows what an application API is. It's an application programming interface. It's a website that you can call. I'm using Postman. Anyone else, you can use whatever you want. You can use curl if you wanted to. I just use Postman to show you. Here's the JSON it returns. So you'll see Chuck Norris doesn't have disk latency because the hard drive knows to hurry up, hurry the hell up. So I don't control the settings. But today, what we're going to do is I'm going to show you this, that I'm going to take that, change it, and turn it into David Perry. So if we hit what I have running right now, oh, which I thought I had running, maybe I don't. Yes, I don't have it running. Just give me a second. There you go. You can't have the demo gods working all the way. There you go. So scientists have estimated that the average, given whatever I can't even read, during the Big Bang is roughly equal to whatever that is, David Perry roundhouse kick. So I'm replacing my name with David Perry. So when we're done here, we're going to be doing React too. It's React Native. Everyone knows React's the only way to go now. Can't do basic HTTP. Got to do all those things. So we're going to do that. We also might have a stretch goal. We'll have a little thing that you see that I just kind of teased here is not Java anymore, but a native application. So actually a binary that'll run on your OS. So think of startup times like very fast. If you saw that startup time I did, it looks like it's Java, but it isn't. It's 0.072 milliseconds to start up. So that's a compile. So everyone, and why I did this talk too, is everyone says Java takes too long to, everything to get ready and get going. Well, we're going to use Spring Boot and give us that Kickstarter to do that. All you need is JDK 17 installed already. We're going to go ahead. Everyone's favorite page that they should be able to go to is start.spring.io. Start.spring.io. If you don't have this bookmarked, bookmark it now. You set up some different things. We're going to go with the 3.0.2 because we don't want to be bleeding edge. So we're not going to do any snapshots. Anything above 3 is the new release. Spring just spent 5 years, I think, around that time developing a new version of the API, and Spring Framework is at 5 something, and then Spring Boot is at 3.0. That's where you can do all your native stuff and they made leaps and bounds on this. So now I'm going to go ahead and we're going to get the different pieces of this, and we're going to say Grail VM native support. We're going to also come down and say, okay, we want the React web. We also want to come down and go down here, and this just helps us set up our project so we don't have to know everything. And my screen got a little bit smaller in doing this, so I have to look a little bit more. Spring Boot actuator. Now, just so I can cheat, I want to make sure I'm going to go into my little projects here just to make sure that I got everything I wanted. I took a little screenshot of it. Spring configurator processor. I guess we could get that one too. That helps you out as developer. So I just wanted to give you that one. Let's see, where is that? Right there. That just helps you in your IDE and your configurations and stuff. Now, all we need to do is say 17, because we're going to do 17. You say, why not 19? Well, 19 is not long-term support. So I'm gonna keep us off the bleeding edge and go with what can potentially get long-term support and a jar, because we're not gonna be in the old cruft of a Tomcat server. It's underneath the covers. And actually, it's not a Tomcat server because React. So Tomcat's not doing the React, it's the Netty server. So we're gonna go ahead and click on generate. And that downloaded the Chuck zip. So oh, okay. And you can record. I'm happy. So I'm gonna go ahead and move this real quick. So I'm gonna take it. So I went to my downloads folder that I already know. And there we go, downloads, and then take Chuck and zip, and then I'm gonna just put it over into my talk folder so that I have it. So everyone following along, I'm just gonna unzip this now. So this is a Mac, you can do, unzips or whatever you want on your heart's content. So now it's unzipped everything. So if we do an LS here, you'll see I have a Chuck folder and do that. We can go ahead, and I'm gonna go ahead and remove my Chuck zip and zip file. There we go. So we should see it. We still have Chuck, but go into the Chuck folder now. You'll see that we have a whole project. So from that start.what? Participation. Yep. Spring.io. That's our place we wanted to go to all the time. So that's where we've gone. Now, what I'm going to do is just say, hey, Dave said I had to have my Java installed. What Java version do I have? And as everyone can see that, maybe I'll make that. Is that better for everyone? Okay, sorry about that. So you'll see that I have a Zulu, which they're from Azul. Great JVM. I highly recommend it. Right now, I want to change my environment to the Grail VM. So I just use Java environment, and I'm going to change to a Grail VM. So now if I do that Java version again, I'm on the Grail VM right now. I can start building and running in my project and get that stuff done. So now enough talk of that. I'm going to open up that project in IntelliJ. So we got that. As when we are doing that, I'm going to just show where we can go outside of the JVM, and you don't need an IDE if you don't want to. You can actually use, now I highly recommend you use an IDE in your daily life to make your life easier and work on things and get things going for your own part of participation in doing your development. If you want to have a text pad and use Java C back in the olden days, yeah, but again, please be productive and use an IDE. I'm running this and just seeing that the boot run is going to run. It's going to compile everything, get it run. It did the Gradle build and build everything. And now boot run should be running. And we'll see though, that I can't call the quote anymore because it's on port 80, but it's not found because we haven't put our controller in. So I'm going to close out of this. I'm going to cancel that one. I'm going to go back to my IDE. I'm going to go into here. There's one thing I got to do only because I do other projects. We're going to pick not JDK 1.8, but we're going to pick the Grail VM 17. And then I'm going here. And I kept this in. I was going to say, hey, I'll just go ahead and not show this and get it all set up for you. But a lot of times your environment setup is one of the things that'll give you a headache. And you'll have a headache and you can't get things going. And you're like, wow, I wish I could have just get this running and doing that. So just everyone has those kind of problems sometimes. So I can sit here and refresh this and it should pick up my JDK in my IDE and everything built successfully. Everyone saw that. So there's all that world. You can do your Gradle and you can do that to double check all your information and see everything running there. Now to the good part. All I'm going to do is create one class. Here's our main class that everything gets started and runs through in Spring Boot. And that's the main application. I'm going to create a controller class, just one Java class that I'm going to tell Spring. And this is going to be our David controller just because I'm terrible of thinking of names. And there we go. This is our controller class. We're going to do some annotations. I'm going to tell Spring, hey, I want this to be a REST controller. And then I'm going to say that the request mapping. Now, if you don't know, or if you do, REST, it's just HTTP formalized protocol that you can do online to HTTP calls back and forth. And the generic side, getting more involved, you can say you have the verbs, you have your different paths, your endpoints, all those kind of things too. And we're saying this is our basic request mapping. So right off the root, coming off of it, it's going to hit this controller. It's listening to that. Now I'm just going to come into here. We're almost done now. I'm going to say, I need a web client. And we're doing React. So I'm going to say, I need a React web client. This comes with Spring in there. We downloaded it with React Native. So now we have the React client. So that allows the request is going to come over here, hit our server. We're going to grab it. We're going to go make a request to Chuck's website. We're going to do some changing on it, and then we're going to send it back. They all talk reactively, and it's all going to go across the board because we're using this React client. If you used another HTTP client that was not React, guess what? Your React will just stop and say, okay, I'll go synchronous, because that's the whole deal. React, asynchronous, reactive, can get shut down back and forth, have a lot of processes, but wherever your stop point is, the game's over with. So a lot of people say, oh, we're doing React. Well, if you don't have it all the way across, you lose out. And there's no real need for it then. So you have to have the call all the way across, or you just have a lot of headache. Now, with that, I need to go grab this Chuck's URL. So I'm going to take from here. I did try to not use the category dev. Well, but you got a whole bunch of other sayings. And believe it or not, they've expanded this API, and some of it is just not good for kids. So hopefully this one, I haven't hit any on this one, so maybe I jinxed myself, but hopefully that's not going to hit. So that's our random guy that we're going to say get us random talks in the category of dev for developers, because that's where it started. Someone did that. So now I'm going to do a mono, because this is reactive, and I'm going to say quote. Now, quote's not an object yet, but we'll get to that. I'm going to say, I want to get my quote. So I come into here, do that. And now I'm going to say, I want to return my quote. So this guy, I'm going to make, that should just let me do it. My IDE would have let me. So every time I want to have it do something cool, it won't do it for me. There we go. Finally, create the class. So, and I wanted it as a, darn, give me 1 second. This is live, so there you go. I'm going to try to get it to go again. This time, I didn't want the default class. I wanted a new record. Does anyone know what the record class is? There it is. I picked the wrong one. So record class is just a way to represent immutable state now in Java. So we're getting all Reacts and be able to do that. So that guy right there, and if I remember correctly, it is just a string for a value. I am actually going to be a little sneaky here. If we go back, getting some feedback. If we go back, do you see where it says value there? So I'm going to take that and I'm going to have it auto fill back in the value. So value to value. So I'm going to go, and there's a little bit of feedback there. Sorry. Okay. So thank you, sir. And now I'm going to go client. Maybe I broke it. This is all reactive. Yep. See, I broke it. Hello, testing.
If I slap it, I'll make it better.
Test, test.
Blow on it.
COVID.
Okay.
No. Okay.
Talk loud for now. I'll see.
Okay. So I can talk loud. That's fine. I don't have a problem with that. So there we go. So we're saying that's that body to mono. So that body to mono, I'm saying that quote class, take the body of that response coming from the check API, put it in my mono. It's going to say, oh, I only have one field called value. I got a JSON field called value coming from check. I'll put together, and that's all you're going to get. That's why you only saw the one. Yes. A mono, it is a type of representation for one thing in reactive. So you're gonna get one and only one of that. So in reactive, you have this paradigm, and that's a container to hold it. So quote is actually the response, but you need this container to hold it to be able to do that. Does that make sense? It doesn't do serializing, deserializing. I'm not going to profess that I am the top-notch reactive guy that wrote in the web server, in the Netty web server, when it comes to reactive. So underneath the covers, like in the C code and the real brainiacs of computer science came up with this. And it's a way to sit down and asynchronously queue up requests. So if you think about it, you're making all these requests to the Chuck API. Well, Chuck API might take a lot longer to respond back. Well, while it's waiting, you can make more requests. You only have a certain amount of time and certain amount of memory space to do requests. That reactive is going to say, hey, you don't have the TCP IP stack right now, so I'm going to put you off to the side, wait for your guy to call back until I get your response. I'm going to use it to make another call. So it's a way to efficiently manage those resources in a reactive way, and you don't have to. So it takes all the complexity and makes us look like rock stars, but these guys who wrote this stuff are the real rock stars. So we're going to do that. And now I'm going to map it. So I'm taking that mapping and I'm going to say, that's a quote. And I'm going to take that quote and go to and say, I'm a new quote. Why am I a new quote? Because I'm using a record class. It's immutable. You cannot put in another value from there because it's immutable. That's beautiful. Remember, we're multi-threaded. Mutability is really bad for us. So now I do that, and the last thing we need to do is I'm going to take this value and I'm going to replace Chuck Norris with what? I'll just say, let's use Danny instead. How about that? There, you can be famous, Danny. That's all we have. So now I got everything in there. And I need my semicolon. There we go. And just so we can see this a little bit cleaner. Does everyone see that? That's all we have. I can do one last thing I forgot to do. The Git mapping. So I'm going to say use quote. And so that is mine. So I'm going to run this now. So I can run it from my IDE, which I'll do here just to show you. You can use your IDE. This will let you debug. So everything works together. You can do it in Gradle. You can do it in your IDE. Why the beautiful thing with Gradle and having Gradle do there? It's your build system. It's your CI/CD pipeline. It's all of that you want going on. You'll see it started up. It took a few seconds to start up, but we're good. 2.333 seconds. A lot slower than that native one that we did in the beginning that I showed you. But I'm going to go ahead and hit it now. And here is Danny's quotes. Did I spell your name right too? So Danny doesn't use Oracle. He is the Oracle. And Danny types with one finger. He points at the keyboard and the keyboard does the rest. So there you go. So that's coming right from there. So that is the whole complete one. Now we're able to spend a little bit more time. I'm going to do some bonus. So just a couple bonus things and I'll be done here. So the one that just is kind of nice, people like this a lot, is I have a banner text. I made this myself. I highly recommended it for your microservices. In the world of microservices, you can bring this in there. Instead of seeing all Spring Boot banners, you can now, and what we'll do is we'll go to the command line now, and I'll run that same Chuck boot run. And you can see now there is my little icon. And now we know it's myself running. And we got it going. So we can hit that again on port 8080. And we'll see that Danny doesn't need garbage collection. There you go. And you guys can read it. From there, the last one that we're gonna do, we're gonna go into Chuck. And this takes a couple minutes, so I always should have kicked it off, but I forgot to do that. And I'm gonna do a native compile. Does anyone know what I mean by native compile? Raise your hands. Anyone? So in Java, it can be slow. Java virtual machine, get everything else. Now what we've done is called Grail VM. It is now being released with the JDK versions now. If you do all the right magic, which Spring Boot 3 has done, because you can't use reflections, because think of this, you're taking all the Java code, that bytecode that's running, it's saying, I know everything in the memory for your bytecode at all that you're going to need. I'm going to compile it to a C program. And now you're native C. No more Java, no more virtual machine. The virtual machine comes in that C code that has that memory footprint. You can do different things to make it take up more memory or less memory and everything else, but it's all in that C program when you launch it. So if you see, there's a lot of things going on here. This is actually, think about it, it's kind of running the program. It's going through all your code and it's going through all of Spring Boot, seeing everything in the reflections and mapping everything and saying, okay, how do I make this into that C code? How can I have it native now? So it's fat. So you remember AWS talked about speeding up the time because of using the new spec that came out. I forget what the spec was that came out. They made, it's kind of like a snapshot of the JVM. This is not that. This is 10 times, this is way faster than that because this isn't starting up a JVM anymore. This is native C code starting up. And I can't, you know, in our class where I'm doing, or at work, where I'm using is a native code running in AWS as a Lambda. So I'm using the custom images that you have to build and run the native, not using the Java when you're doing that. And you'll see it's almost done. As soon as it's done, I'll go ahead. I'm going to cancel that one and we'll go into the native folder because that's our last thing we have to do. So in the build, in the native folder will come a native compiled Chuck program. So we'll see here in a minute because we're impatient. We're like, hey, let's go. Can it be faster? But just a second. I just like to be impatient. And after this, that's it. That'll be the end of the talk. I just want to show you that C. Remember that time that we had. What was it? Like 1 or 2 seconds or something like that? Or 1 second or 2 seconds. Now we're going to go. It's almost done. Come on, you can do it. So you have to think about this too, though, what's happening right now. I mean, it really is inspecting all those objects. And anyone knows Spring Boot and all these things that it has, they've taken a lot of time, a lot of really smart people and have done this mapping. And you too can do this. So you can make your own classes and do all the mapping too. So if you do reflections, Spring Boot has a thing to help you define your reflections of your objects of what you need and to do that. So right here, we see that there's our Chuck. I'm going to run it because I'm on a Mac. So /Chuck because Mac or Linux, not Windows. And there you go. We're done. And you'll see we'll get a quote. And there you go. Danny's log statements are always at the fatal level. We're done. And you'll see the startup time too, 0.086. It's C code. So thank you so much. That's it.
So without further ado, I'm going to be giving the floor to our very next speaker, Neil Chowdhury, who is the president of Videosaurus. Thank you so much for being part of this. And he's actually joining us from DC. So I said he could be an honorary Texan for the night and kind of hang out with us and deliver his talk. So we're going to test this out. Neil, can you see if you have the ability to share your screen now?
I will try. Hold on. Okay, do that. Do that.
Perfect. All right, the floor is yours.
Can you see
Neil.
the slides?
We can.
Oh, yes. Okay. Awesome. All right. Well, hey, y'all. You know, I wish I could be down there with you. I miss Whataburger a lot. So thank you. Thank you, Danny. Thank you, David. And thank you all for the opportunity. This is Reactive Programming in Spring Boot. I'm your host, Neil Chowdhury. So here's a little bit about me. I'm the president of a company called Vidya. I've been in the game for a long time, done a lot of things, and I love what I do. And that's enough about me. So now, when it comes to reactive programming, it all starts with the reactive manifesto, which is right here for all you can see. And it basically defines a lot of the key theoretical and academic principles that that form the basis for reactive programming. But I will say, and please go ahead and read it if you like. It's like I said, pretty straightforward. But are we good? Or I think I might have lost something here. Hold on. Okay, are we good now? Sorry.
You're good. I'm just trying to put your face on the screen at the same time.
I see. Okay, cool. Yeah, so basically, yeah, so the reactive manifesto is here, and it basically forms the academic and theoretical foundations for what makes reactive programming. Now, I will say that while it is important to look at these principles and understand them, I think the key thing to consider is really more about what are the practical realities of this technology? How can it deliver for you, your team, and your customer? And so if I were to boil reactive down into a straightforward few words, it's this. And there's good news and there's bad news. The bad news is that every day we're building software that's more complex with more users and more data coming at you with more speed. But the good news is we have better machines with more power, more memory, more CPU and threads. And reactive programming is about allowing us to harness that power to produce software that's resilient to change and fault tolerant at scale. And that is super important because, hear me now?
Oh yeah, we can. The debugging. Yeah, there we go.
Okay, sorry about that, everyone. All right, so as I was saying, the key thing is to harness the power of your machine to meet those challenges. And the thing is, if you don't do that, then all of a sudden your software is no longer resilient to change. It's not fault tolerant. It's not going to scale. And then you get very, very important people very, very mad at you. And you don't want that. So there we are. You do not want very, very important people very mad at you because your software can't scale. Now, before we get into the details of reactive programming, let's consider this metaphor to help understand a little bit better. So imagine it's Friday night and you've been coding all day and all night. You've been in the zone and you realize it's like 2 a.m. and you're hungry, you haven't eaten. So you head over to the fast food joint and you see two people working there and you just say, hey, can I get a burger with no pickles, some fries, and a drink? And your server takes your order and heads over for a fresh burger with no pickles and waits. And waits. Gets the burger, puts it in a bag, goes over to the fries. Oh, there's no fries available. Time to heat those up and salt them and wait. Meanwhile, someone else has come in talking to the other server. Same thing's happening to them. Your server goes and tries to get you a drink. Meanwhile, it's late on a Friday. The bars and the clubs are letting out, and all these drunk people are rolling into the restaurants, and they're starving. And there are big lines forming behind you, and they're going to start to get angry because they can't be served because all these servers are waiting for everything to happen. And this is analogous to what it's like in the traditional servlet model, where you have one thread per request, and that thread goes and it does what it needs to do to support you, make an API call, hit the database, hit a cache, or send an email, that kind of thing. And every time it's waiting and waiting, and all these other threads are sort of queuing up behind you, and they can't be served, and all of a sudden Ticketmaster can't sell Taylor Swift tickets. Now, contrast that with the model we're used to seeing at a restaurant, where people go in and there's an entire team back there, and as you provide your order, they're calling it out, which is a form of message passing, if you will, calling out what you need. Everyone's preparing, there's no waste, there's some waiting still, but everyone's working and collaborating to get everyone out the door faster, and that's the key thing. So it's not going to make the fries cook any faster, And similarly, your database calls or your API calls won't get any faster, but it gets everyone out sooner, which is the key for scaling and producing fault tolerant systems. So now something else we want to talk about when it comes to the theoretical and academic aspect of reactive is the idea of reactive streams. And here we're using the concepts of reactive programming to handle theoretically infinite streams of data from an IoT device or from a Kafka queue or what have you. And it's also the key thing here is handling what's called back pressure. The idea here that we want to throttle the amount of data coming at you so that it doesn't overwhelm the resources. Because if the data come at you too fast and your services can't process them in time, then all of a sudden you're no longer resilient. And we've seen this happen to very powerful computer scientists. And so when everything starts moving too quickly, then all of a sudden you start getting overwhelmed and you can't be resilient, you can't be fault tolerant, you can't serve the new requests that are coming in time. And so this is what reactive is about, and reactive streams in particular about managing that back pressure. So now everything I've said so far applies across programming stacks. So let's zero in on Java. In Java, we have Project Reactor, and the primitives here that support reactive programming are scheduler, which keeps track of everything that's going on and manages back pressure. Publisher, which is basically anything that's emitting data to you. And there's two special kinds of publishers, Mono and Flux, which we'll get into in a second, and Dave already talked about a little bit. And subscriber, which consumes data as it comes in. And notice also these are all type parameterized, so we know the types of data that are being published and or subscribed. Zooming in even further, we get into Spring Web Flux, which is the next generation web framework for full support for all the reactive principles. You see here the Venn diagram. This is from the Spring website that shows how Spring Web Flux relates to the OG Spring MVC. And I also point out here at the bottom that a big part of reactive is functional. Now, functional programming and reactive programming are different, but they're such a natural fit together that you often hear the term functional reactive programming. It's like peanut butter and jelly. They just go very naturally together because the ideas of functional programming like immutability, like composability, building data pipelines where you're assembling one function after the next, that goes very well with the idea of reactive programming as you subscribe to various publishers. And of course, in Java, we do that with Java Lambdas. As I mentioned, there are Mono and Flux are the two big primitives in Spring Boot. And I think Dave talked about these a little bit already. Mono, as he mentioned, it basically is like the reactive version of optional. So some of you may know that optional represents data that has a cardinality of 0 or 1. A common example of this is like a find by ID call to a database where you'll either hit on that ID and get the value, or you won't. So you'll get 0 or 1 of them. Meanwhile, a flux is like a reactive list, except that lists are finite and they exist in memory. Whereas a flux is really just an incoming stream of data pinging at you every so often. So it represents a theoretically infinite stream of data, but you can sort of think of it like a reactive list. So now at long last, we finally have some code to look at. Sorry it took so long, but I wanted to establish some of those theoretical foundations to give you some context to what we're getting into now. So here is a hard-coded kind of fake Mono just to get our feet wet. So here's a method called getGreeting, which is a Spring Boot controller method for an endpoint for a REST API. And all we're doing here is we're taking the value name from the path parameter, using it to create a formatted string and wrapping that up inside of a Mono, similar to what Dave did earlier. So now we're simply returning a Mono of string, which again is sort of a reactive artifact around string that's 0 or 1 cardinality, in this case 1, because you are returning that string. So that's getting our feet wet with these reactive primitives, but now let's have some more fun here. So this is a method called getPets, and keep this in mind because we'll refer to it later too. GetPets returns a flux of pets at a theoretically infinite number of pet records. And we're setting up, most of this method is really setting up web client, which Dave already talked about, so I won't spend too much time on that. And we're using web client, which is the reactive analog to the OG Spring REST template for making API calls. And most of this code is setting that up to make the call to the Swagger Pet Store API, which is a real API that's out there, similar to the Chuck Norris one that Dave had. And we're basically making a call to that API to find all pets who are available and passing that through to our consumer as a flux of pets. So we're going and fetching that JSON and basically returning the same JSON to our consumer. Now, a couple of subtle things here that some advanced devs might know. First is that when we get the JSON response from the pet store, it's being deserialized to Java by Jackson because it's sitting in the class path of our project, and Spring Boot's very smart like that. But then only to reserialize those records back into JSON on the way out. So you wouldn't do this in real life because it's kind of a performance hit for no reason. Why would you deserialize in the Java only to reserialize back out? But just to show you that when you fetch those JSON records, you could then do, for example, a mapping to a different kind of data type at the end of this method and return that as a flux on the way out. And again, that's a theoretically infinite list that's coming on the way out. Now, I wrote this fake database to sort of simulate what it might be like to hit a real database, but with a reactive driver, which is a thing. You can get reactive drivers for Postgres or Oracle or whatever. So imagine an adoption applicant database. And here we have this find all method that's, again, just pretend, but we're going to return from this quote unquote database a flux of adoption applicants. And the way we do that is by using the range factory method, which just says generate 20 values in the flux with those 1 through 20 numbers, and then map those numbers as an ID to an adoption applicant record. So those numbers become the applicant's ID, and I'm using the Java library faker to add a fake name. And so now you have a flux of adoption applicants. Keep that in mind for later. So now what we want to do is the fun part, which is we have a flux of pets from the pet store, and we have a flux of applicants from our fake database. Let's pair them up. Let's do some adoptions. Let's get these animals our forever home. So we call find all, which is that fake method I just showed you, that returns a flux of applicants. And we're calling the zip with method, which basically will combine by aligning, think of it this way, you're aligning one flux with the other flux being from the getPets method, which is the first parameter. And that getPets method, as you remember, is returns a flux of the pets from the pet store. So as we proceed down and traverse the flux for each one by one, we get a pair of an applicant and a pet, which is why our second parameter is a lambda that says, given an applicant from one flux and a pet from the other, let's adopt and have a new adoption record with the name of the applicant and the pet information. So this lets us combine fluxes in order to make new objects. So I wanted to get into error handling a little bit. And here I basically try to fake errors. We added another method here to the applicant database, and it's called find applicants but error, and it returns a flux of adoption applicant. And I just use some of the other flux factory methods like concat and just and error. You basically have a pretend flux that has 3 legitimate data elements and an error stuck in the middle there. Okay. So now there are a lot of different ways to handle errors, and it always depends on what you want to do and how do you want to solve these problems. Well, in this example, what we're going to do is use on error return to return a hard-coded value. So let's step back. We call that find applicants but error database method, fake database method. returns a flux of adoption applicants with that error buried in the middle. Then we have a do on error method, which basically is a method that takes a lambda, and that lambda with the parameter being the exception or whatever error that happened, and it lets us perform a side effect. Typically you'll log in a do on error, but whatever you want to do, whatever side effect you want to perform. So we're doing that. And then we're saying, you know what, we're going to be optimistic here. That's probably a momentary glitch. These things can literally resolve themselves in a matter of milliseconds. So we're going to retry one more time, give another shot. And if that doesn't work and we still have an error, then we call on error return to return a hard-coded value. In this case, it's just a dummy adoption applicant with a -1 value for the ID and an empty string. So that's one way to handle errors, with this sort of hard-coded stub, if you will, for the error. Now, here's another way, a little bit more flexible. Now, there's a lot going on in this method, so I'm going to try to walk through here pretty slowly. What I'm going for, because this is another Spring Boot API controller method, is I want to return, in the case of an error, an empty array, which sounds like not a big deal, except that keep in mind that there are multiple reasons you could have an empty array, such as there are no applicants for adoption, which would be sad. But keep in mind now, we want our consumer to know the difference. Am I getting an empty array because there were just no values? Or am I getting an empty array because there was an error? And so the way I'm choosing to do that is by differentiating with the HTTP response code. 200 if it's a legitimate just empty, or 500 if it's because of an error. So that's kind of the requirements, if you will, for this method. So this method is called get applicants with error resume, and it has a fairly complicated return type, a mono of a response entity of a list of adoption applicants. So let's walk through that slowly. So first, we're calling find applicants but error to get that flux of adoption applicants. Then there's this collect list method, which what this lets you do is it lets you accumulate the flux into a conventional list in memory like we've always used, an array list. You won't always use this, but in this example, I feel like, I can get away with this and it's fine. It'll accumulate all these in memory. So I now have an array list or a list of these applicants. And I can call map, which is always, as you know, a transformation function that says, okay, given this list of applicants, I want to return a response entity, which is just the normal Spring Boot thing, not a reactive thing. It's always been there. With the applicants as JSON, thanks to Jackson being in the class path, and a status of okay, a 200, because it's just a normal empty array. But if there's a problem, then we call do on error to log that error again. And now we have this method on error resume. This is a much more flexible method than before, because now it's not just a hard-coded return value, but in fact, a full lambda that we can do whatever we want. And what I'm choosing to do is to create a response entity, which is basically like a response body, but typed for Spring Boot. And with an empty array list and the internal server error 500 coming out. So you'll get either an empty array with a 200 or an empty array with a 500. So the API consumer can know the difference. Okay, we're getting near the end here. So some quick testing notes. We can test our reactive code with the reactor test library. And we have two primitives, the test publisher, which is a mock publisher, and the step verifier, which is a mock subscriber. Now, I will get on a little bit of a soapbox here and say that I tend to believe that testing in tech is largely broken, that most of our tests are built or written to satisfy or to check a box on code coverage rather than to write tests that actually give us confidence that our code works and to minimize errors in production. And so why do I bring this up here? It's because I want to suggest to you that you only use test publisher and step verifier when you're really truly testing reactivity. So if I want to test that my business logic is right inside of a lambda or a method, don't do this. If I want to test that my query is correct and I'm fetching the right stuff from the database, don't do this. Use reactive testing primitives for actual reactive tests, where I want to test, for example, how am I error handling on different kinds of values in my flux? How am I handling different durations of one item comes in 100 milliseconds, another one comes 2 seconds later, and they're varied. How am I handling that? Those kinds of things. Use the reactive primitives to test reactivity, and use other more conventional methods that you're used to for testing other things that you might also care about. Now, something I'll also add, which is parroting off of the great Charity Majors, who's one of the leading experts in the world on observability and monitoring your code in production, which is that even if you test everything great, it can only get you so far. There's a certain point of diminishing returns where, because we're dealing with these, threads working inside our machines, there could be weird network things happening. Who knows what kind of scale you're hitting or what kinds of data are coming at you that might be weird or unexpected. It can be very hard to test for everything. In fact, it's impossible. So you do what you can, you make your good faith effort to test as well as you can. But in the end, especially with reactive things and all these crazy threads and all these things going on, you really need your instrumentation, your observability, and your DevSecOps pipeline to be on point, meaning that you want to really know what's happening in production. You want to know what your memory is doing, what all your threads are doing. Try to figure out what could be causing this problem. And once you have some ideas, try to reproduce it with these primitives. And then eventually, when you feel like you're ready, then get that code out there as quickly as possible through your hard-coded, or excuse me, your hardcore DevSecOps pipeline. So
Morning.
that's be on point as well. And with that, thank you so much for your time and for this opportunity. It was great talking about this, and I hope you learned something and hope I was helpful to you. Thank you.
Thank you.
Are there any
Oh,
questions?
on the camera back.
You can ask me, or you can, the code for this is in GitHub already. I will post the link, and I will also post these slides on the meetup page as well.
Awesome stuff. So without further ado, we're going to be moving on to our next speaker. So it's Ariel, Michelle, it's Ariel Bowen.
Hi, can you guys hear me?
Yes.
Okay, good. So
Neil, we
don't-
need you to stop sharing yours and let's see.
did.
Hold
Yeah,
on
I
one
did.
second. Ariel, I think you should be able to share yours. You want to try now?
yes. All right, are you all able to see it?
Perfect. We
Okay.
can see it.
All right, perfect. So I had a PowerPoint, but I guess I didn't save it and it wasn't auto-saved and I closed out of it. So we are basically freestyling this. I do want to give a brief introduction on who I am. So again, my name is Ariel Bowen. I currently work at McKinsey & Company as a software engineer. I am more junior level. So this is my first speaking engagement, so be nice to me. And what I want to talk about is ChatGPT. We already know, like, it's like the hot new thing right now, and like everyone wants to know, how can we use this in our daily workflow? So this is how I use ChatGPT as a junior engineer. So there are definitely some do's and don'ts with ChatGPT. I definitely don't advise to use this as a crutch. I don't advise to like actually use this to create your components. This is mainly for if you don't have a senior developer available, you don't have a team lead, and you just kind of want an idea on a path to follow to fix a bug. So for example, I have this, I received this bug before. And so all I did was plug it into ChatGPT, and ChatGPT will explain to you what the bug is, what it does, and how to go about fixing it. So it'll then tell you is an example of how to put the dependencies in there, because this was a dependency issue. It'll give you an example of what the code should look like for the dependency issues. And then you can go in and you can fix it. So I also use this in conjunction with Stack Overflow. So when I go into Stack Overflow and I put in the exact code, the error message that I got, sometimes all of the information that comes up is like, it's very overwhelming to me. So like all of this right here, this would overwhelm me and I wouldn't know where to go. But using ChatGPT, it tells you exactly where to go, where it says this error can occur if Spring Boot library is not properly included in the project. Like it gives you very, very layman's terms what to do. So then it'll also give you another example on how to include it in the project. So this is exactly what it's supposed to look like. And this is the language. And you can even ask it, what language is this? And you can ask it to put it in a different language if you're coding in a different language. And then right here, it'll then say, you know, once you've properly included it and, you know, and everything is compiled, then you shouldn't have that error. So that's one way that I used it. And another bug that I've gotten before, and that you'll probably get a lot as a junior developer, is a compiled Java error. And this is, I believe, the best example of how to use this. So right here, it gives you every last reason for why you could possibly get this. So you would start here, which is your syntax errors. You go in your code and you double check your syntax and making sure that there's no semicolons, no, you got your system.log, you got all of that. You got your parentheses where they need to be, you got your brackets where they need to be. All right, so then we're moving on. We're going to our dependencies. This is when you can then bring in other people of the team and say, hey, I've already gone through, you know, boom, 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 I've already gone through these steps. Maybe I'm missing some dependencies. And then you can go through your libraries and your dependencies to make sure you have everything that you're supposed to have. And then next, it could be your incorrect class path or configuration, or a configuration in your build system. I'm sorry. So after that, again, you've got your next step in your troubleshooting process. And you can go through all of your class paths and your environment variables and make sure you have all of that completed. And then next, you've got your conflicts between versions of the same library, which this was actually my particular issue when I received this error. So if I didn't have this step-by-step guide, then I just would have been Googling all day and on Stack Overflow, trying different options and waiting around for a senior developer or someone else on the team to kind of guide me through what to do. But with ChatGPT, it's definitely streamlined that process, and it has resulted in way less downtime for me. So, you know, again, I don't advise you actually put any classified information into ChatGPT. I don't advise you put any like actual class names or anything like that. I only advise that you put just the bugs in there, and like just go through the steps. And I think it's a wonderful tool. Again, it's not specific to Java, but I feel like when you're learning Java and like say you're on the job, or you know, you just don't have that, you don't have someone there holding your hand, so to speak, then you have basically like a senior developer right there walking you through the steps. So this was like another error message that kind of was like right up there with this one. And that's why I said there was a conflict. And whenever I would try to run the code, not only would I get that, but I would also get this deprecated Gradle features. So then you can ask, hey, like, what should I do? And they'll give, you know, chat will give you the steps on what to do and say, hey, maybe you should try this. So that was just a quick little blurb about using ChatGPT as a very important tool when you are learning Java and when you're on the job, not as a crutch. Again, I'm going to say that again because I know everybody's like, oh no, to ChatGPT and it's cheating. I don't think it's cheating if you're using it ethically. Like you already know if you're working in a particular environment like mine, like I work, for McKinsey, a company, and they are very, basically there's certain things that you can and can't not take out of the software development environment. So again, don't put any classified information in there, but always just use the tools that you have available and use it right alongside Stack Overflow. You don't have to wait to have a senior developer there. You don't have to be overwhelmed. Just add it to your workflow, and I think you would see a lot of progress in your learning.
Thank you so much, Ariel. Appreciate that. The one caveat I do like to say when it comes to the subject of ChatGPT is it's very confident even when it's wrong. So whatever it gives you, vet that information, check it out, because I've seen so many instances of it having a bad answer that it just deems correct, and you'd be none the wiser. I actually had somebody tweet at me the other day and basically say, what did they ask it? It was what's 2 + 5? And it ended up saying some random integer that was the actual correct answer. They tweeted that at me. So it's definitely good when it's right, but when it's wrong, you definitely have to make sure you're checking that out before going down that path.
Absolutely. And that's why I always say, just you make sure you're actually using it with Stack Overflow as well. And like you're double checking with your other developers on your team as well.
Absolutely.
So I just only use it just to kind of like give me a guideline on where to look, and not so much what code to use, if that makes sense.
Absolutely. Well, thank you so much,
you.
Ariel. We
Thank
are
you.
now, go ahead. What she said? Oh, perfect. It's like an echo in my ear up here. I don't know why, but all right. So without further ado, we're going to be moving on to our next speaker. That was our last virtual speaker. And our next speaker is actually going to be Chris Mackey, who's an automation test engineer for iStation. Chris.
Good evening. My name is Chris McKay. I have been a software engineer for over 20 years. And from what I've learned, software engineering is a team sport. So I want you to help me test my work. So take a moment, look at it, let it percolate in your mind. All right, everybody's got it? So when you look at this, do they all look like yes or no type answers? No, that's great. Does anyone have an it depends? All right. Anyone out in virtual land have an it depends? Well, that is perfect, because the requirements of software are just so ambiguous. And it's that ambiguity that allows programs to slip out and we have a bad experience. Who here has waited for the cable guy forever? And then they talk about it. It's like, you know what, I hate that cable company. And then they tell someone else, and then their sales start dropping. What we want for our software that we work so hard on is to be a positive experience. And it was mentioned today about testing. Yes, it's impossible to test and have perfect software. I tried sacrificing a goat, it still doesn't happen. But we still hope that we can eliminate bugs, and that through all our testing processes, it can be as good as we hope. Now, automated testing can take care of a lot of the manual processes. I've done manual testing and it is very rigorous, but there are times when it's like, yeah, you know what, I'm really tired. I just need it to do something for me. Can this website just type itself? And then I found automated testing. It's absolutely great. It takes care of the regression testing. If there's a new build, it will pick up that build, run tests and say, you know what? You did not have enough coffee when you put this particular load in. Why don't you go try again and kick that back out? So it frees up resources to do more manual testing and do discovery of those bugs that we just don't find and are really, really interesting. Now, there's a lot of testing that can go on, including cross-browser testing, performance testing. I'm not going to cover that. We're going to cover techniques and software, specifically Java, just for UI, API, and load testing. So as I mentioned, my fingers get tired of just clicking on the web. There's some great things you can do on websites and great applications. However, they need a human being to move it up and down and interact to know if it's working. Selenium takes care of that for you. It can click, it can scroll, it can minimize, it can maximize. It can do most of the things that a human being can do. But guess what? It doesn't get tired. It can keep on going and going. It is the Energizer Bunny. And it doesn't just work with one. It can work with Selenium Grid, and you can run several tests in parallel, great for saving time. Now, to find these elements on the web page, we use locators. So going into something like Chrome DevTools, you can go pull up the element. Actually, I won't jump to that because that is on my next slide. Show a quick example. I've worked with a lot of developers, and for the web page, the locators are put in. I always like to work with putting particular items, having a specific class name so that I can find items. ID is like the holy grail because IDs are unique on a page. I can find anything. I can find a button. I can find a link. It's just great. And my work is taken care of. So those kind of examples, it's always great to put on your webpage when you're doing development because it helps automated QA. And it also helps having uniformity inside your page. So Selenium uses that driver with the find element of by locator to find whatever type of piece of class name, link, XPath. So here's an example going to a page. It sees login. You want to find that login. So instead of looking for login, you would look within the actual HTML code, go in there with Chrome DevTools, and find in there, we find our login. We've opened up the driver, called up the web page and navigated to it. Look for that link test where it says login. You see the same login in our text. It's like, yay. That's great. I was able to do something. I was able to do something simple and I feel accomplished. Now I can go and have a Snickers bar because my work is done. That was great. However, tests are not that simple. Most applications can run in nearly any language, C++, Python, Node, of course, Java Spring. But your test scripts do not need to be in the same language. I use Java to call Selenium WebDriver to do that work for me and test complicated logic. Now the tests can be quite complicated. So you do fall into a pattern. You start off with ideas. Who here has ever played with Legos? Who here has ever stepped on a Lego? They go everywhere. So that's where my ideas are. But my ideas need to be collected and organized in a nice, beautiful house. But how do we get there? We take our patterns, we build our outside walls, we add our roof, we make our furniture, we put the whole thing together and we get our wonderful house. But it's following those patterns over and over again, and we begin to recognize them. Just like when I was little, somebody gave me something, my mother used to say, "What do you say?" I said, "Can I have some more?" That didn't go over well. I was supposed to say thank you. So that is the pattern. So we learned please and thank you. And there are similar design patterns for implementing sections of code, in particular for test automation. Now, there are at least over 20 design patterns. With respect to test automation, we're going to just touch on 4. Specifically for those, the rest apply to more of the business patterns deeper into there. Where creational is about building your class, structural, putting those components together in behavioral, making sure that those components are talking. So our first pattern is the singleton. I'm covering this in an overview, and it's great that these are going to be separated out because these will stick with you. And then you can take this as a reference for building this if you decide that you want to learn how to automate your test code so it can enhance any of the unit tests that you're doing on your code already. So with our design pattern singleton, we want to make sure that we have just one instance. And with that, we just want to use it one time. It's like, well, why would we want to do that? When you start up the Selenium WebDriver, you only want to call it once. It makes that glue, but we don't want to start it again because we still want to use that same instance because that's how it knows where the browser is. It's like, who am I talking to? Oh, I'm talking to you. So we want to have that same item. We want to have just one item for connecting to a database because that is the database that we're getting from. We're running our SQL queries against it so we can get our information. I use test-driven development and call in Excel files, but I only want to pull it in once. So we just want to do it in once. And of course, I want my answers to go out. So I want my log files. So making a singleton to just do things once, so it's taking that action, takes care of that, and make sure it is made, and then it makes sure that if somebody else asks for it, I'm using the same one. Now that's a template. So template is pretty much in the name. It offers a skeleton where we're defining the steps of what we need to do. So you've probably done this in life. The great thing about class is that they often follow real world examples. So think about when you took your last trip, you got on some website, now Google does everything. It does your hotel and your car and probably plan some other things. Inside all those bookings, even though they are different, there's some parts that are the same. You need to store some items and do the same thing. The template allows that. So from your perspective of the class, you're doing something different, but the meat of it is the same. So I've used this for students registering in math classes. They're all going to class, but there are differences between going to reading and their math. They take different tests, they have different information, but in the center of it, it's still the same. So we look at the algorithm and say, well, what am I trying to do? That's where we pull out the item of, this is the class where I'm going to make it. Which standards and steps do I need for the action that I'm doing, for the 1 through 10 steps, but what's the meat of it? And then being able to reuse it so I can minimize my coding and minimize where I need to unit test and integrate test and look for any errors. So there are a lot of really complicated classes out there, but Facade is greater for making an interface that makes something easier to use. So if you're doing something that requires a bunch of steps on the inside, like a recipe, Facade is a good one. It collects all that and obscures it. It's different from the other parts of the steps because those, where we saw with the template, these steps are all together. So imagine if you're looking for a particular document, you put in your search term, you apply some filters, get the results and pick what you want. And then sort through to make sure that that is correct. The Facade is taking care of that for you. So we put things in a wrapper, a nice bow around it, and make sure that everything's okay so we can access the classes in a neat and orderly manner. Now this does wrap up things. So if you're a power user, that stuff's hidden. You need to go there and you need to go to developer. It's like, can I have access to the class? No, you can't have it because this is how you're getting in. And then once again, Candy opens doors. Just remember, Candy always opens doors. That's what I found. And it's those kind of doors that allow you to extend something else. This particular pattern is not on the other list. It is one that is a hybrid that has been developed from the test automation, is the page object model. So from the beginning, you saw where I labeled the selectors, and you're like, what am I doing? I'm looking at it as a human being. You can go through, I know how to log in, I know how to click a button, but as a machine, I need to know what those differences are and then find them. So those differences get incorporated into the page object model, and you build the model for that. So as you're going through and testing, you're looking for the different pieces. Similar to Facade and Adapter, but more geared toward UI. And finally, we've seen the builder. We saw that with the APIs that were being used. They're methods that are put together. From this point, we might see it more in I typically use it with a request response pair, building the class, building a specific item to look for a response of hitting into the database. So in combination with this, I'll send my API call, send it, get what I hope will be back, and then use a singleton, make a SQL call to do a get to wonder, well, do these match? I really, really hope they match. One of the great libraries for using is the Rest Assured library. It was originally written in Java. It's a great library. Go out and find it. There's a link at the end of this where they have a whole workshop that you can play with this in order to do testing. Now, lots been covered about patterns. Now, we saw patterns, there were about 26 of them, and we covered 4 or 5, but the key thing are the object-oriented principles. They are the foundation, which is why I found this wonderful foundation Lego block of going through encapsulation. So we wrap up our data. And if you're a new programmer, these are the questions that they always ask you on the interview, and they give it to some HR person. So you have to get these absolutely right. You should just memorize them, just tattoo them on your arm. What are the 4 things? So you can just call them out and memorize it so that you can pass through the HR gate. Encapsulation is just hiding something. I ask you a question and it goes, nope, you can't have it. You can't get to this. Call my method, you'll get it from there. Inheritance is just putting things together. I've come from other object-oriented languages, C++, you can throw all kind of things together. Java only lets you inherit one. Like they just said, hey, we're not gonna let you mess anything up, so we're not going to let you do it. I really don't like being limited, but that's a whole other story on that. Polymorphism is great when you're trying to do different types of things to different objects and have them do different actions. A simple item is when we try and add two integers. It's different from adding two floats, or might be different from adding two objects. Polymorphism can make a plus act the same way and put some kind of intelligence, so all that stuff is magic to the user. And abstraction is just hiding things away. Now, the page object model, that hybrid one, is one that encourages just wrapping things up and hiding them. The final tool is not you programming, in a sense. It's you using a tool and you give it instructions. It's for load testing. So just putting a program out there isn't enough. As we saw from the Taylor Swift example, loads can just bring things down. I usually see loads from previous jobs, the Black Friday shopping, and being able to handle that scaling. Right now in iStation, where we handle students. So being able to handle those loads of tests and students coming in to take tests and do their lessons, you need to be able to scale to handle this well. So tools like JMeter, which is a Java tool, can test that and run performance testing. Are there any questions? I cannot see the chat. No? That is great. So there are lots of links to do. If you're interested in learning more about testing, there's Test Automation University. Even though it has the word university in it, it is free. And I know a lot of you already know about Free Code Camp and the information it provides. Thank you.
Being here tonight, and hello to everybody online as well. My name is Jordan Parker. I'm a software engineer at JP Morgan Chase, which is actually like right around the corner from here. So it took me no time to get here. With that said, just a little quick background on me. I'm probably about 3 to 4 years experience now. And I started off in like a boot camp. That's actually right around the time I met Danny's, when I was going through the boot camp and met him at a meetup. So we go back a few years. So I'm not going to give him his little dirt today, but anyways, with that said, I spent about 3 years working for pretty big corporations, BlackRock, Citibank, and then I just moved to JP, like I said. So with that said, we're going to go ahead and move into a not so exciting topic, but very necessary, exceptions and how to handle them. And if every developer knows it's impossible to avoid them, so why not figure out how to handle them? So let's go ahead and move in. So one thing I want to get out the way first, there is a difference between exceptions and errors. Exceptions are something that is done usually by the programmer's hands, whereas errors are something that is done by the system itself. So you can come across many different examples. Maybe for errors, you may have out of memory type of the error, whereas exceptions, you can always have like an array index out of bounds. Another thing is that exceptions can be recovered. We like to say it's failed gracefully. So with that, errors cannot be handled. Once it happens, your application it's gone, it's down. So you have to go manually figure out what's going on with the application itself or the systems using the application. And then with another thing with exceptions, they can be checked or unchecked, which just means that if they're checked, they're done at compile time, which means your compiler, your IDE is going to yell at you before you can even start the code. Whereas unchecked, which is done at runtime, it's going to happen when you execute a method or even when you start up your application sometimes. Whereas errors, they're all unchecked. Again, there's just nothing you can do about them. And exceptions, usually, again, are done due to programming errors, whereas errors are just, again, due to your system. So you get to take the liberty of not blaming yourself for that happening. So what does an exception look like? If you're blessed or if you're just starting out, look at the picture on the left here. It's just a simple index out of bounds. Consider it lucky if you do get this. There's not a lot to look through. However, on the right here, this is another exception. It's a null pointer, but the problem with it really is that there's a lot more to look through, and kind of eats away at your time when you're trying to get through a task or figure out what the issue is in exceptions. And they can even get worse than this, where they're like referencing multiple classes where you may have a mistake. And so it could take a long time to figure out what the issue is, where the problem is located, and what to do about it. So generally, what happens when an exception occurs? Well, long story short, your application crashes and you have to manually go back and restart it. That's pretty self-explanatory. When you work at a large company, though, that is a huge problem. Anytime systems go down for even just a minute or two, you're probably costing the company millions of dollars if you're working at these larger corporations. So you really want to figure out ways in which you can not cause the company a loss of a lot of money or damages that we can't even handle ourselves. So the best thing we could do is figure out how to resolve that. And so some common exceptions you may have already come across are file not found exceptions, SQL exceptions, and class not found exceptions. And these will be considered compile time. So like I said earlier, if you have a compile time type of error, your IDE will yell at you. It usually highlights your code red and says, hey, this file doesn't exist even though you're trying to call it, or hey, you're about to have a SQL exception due to a mistype of whatever you might have typed into the SQL. Now, another type, again, the unchecked exceptions or the runtime exceptions. These would be your null pointer. And trust me, I don't care how many years of experience you have in programming, you will always come across these. It's just like, they're unavoidable, they're there. Array index out of bounds is a very common one. I used to experience a lot when I first started out. Every once in a while, I'll still experience them, especially if like I'm really nervous in an interview or something, and that just kind of goes south. We're not going to get into interviews. Those are just scary all around. But moving onwards, so we want to figure out how to handle your problems as far as exceptions go. So when you are unsure when you are unsure what your code logic may do or any business logic that you may have, you always want to try to put it in a try catch. And it took me an embarrassingly long amount of time to figure out what a try catch does. But I ended up learning what it does anyway. So what this actually allows you to do is that when you try a piece of business logic, whether it be business logic, SQL logic, whatever it may be inside of your code, it if an exception decides to happen, what it'll do, it'll catch it. And this allows you the time to usually log it, maybe get the print stack trace. I would try to avoid that most of the time, but we'll get to that in a second. And then what that does after that, you can use a finally, which allows you to, again, log another message to your user or whoever may be handling the code that you've written. And this also allows you to keep your app from crashing, which is like the most important thing. So if you see here on the right with this little code I have set up, it's just simple print statements, nothing too wild. But you can see here, if you're looking at the print statements below, I'm doing an iteration over a for loop and then kind of color coded to make a difference, but it lets you know that it's caught an exception and it'll print the message below. So I just kind of took the exception message and just printed that statement out as well. And then under it, you can see that the code that I have, the second for loop, still is able to run even though an exception has happened. And that's usually the kind of practice you want to keep moving, just so you don't have any like mishaps doing work or like send up anything in production that does not need to be there. So some of the best practices when using a try catch or just handling errors in general, you want to use any kind of cleaning up of resources in your finally block. I wouldn't necessarily try to run any more extra logic in your finally. That could probably cause errors that you don't want later on. But also moving into that with your catch statements, you want to give the most specific exception you can. So if you've ever thrown a try catch or ever thrown, my fault, if you ever thrown an exception, exceptions are very general, very broad. Anything could happen within them and doesn't give any developer or whoever is using your logic at the time to understand what is really going on. So you try to be a little more specific. A good example is me, let's say, throwing a data integrity violation exception, which is usually revolving around maybe like a key constraint or something of that nature. And another best practice to keep in mind is just make sure you document, because you may not always be the one may not be the one always handling your code per se. You may have to hand it off to another developer, and you want to make sure that they understand that there's a possibility that if an exception happened, it is due to X, Y, and Z. It's easy for us as developers that when we write a code, we know what's going on, but we also forget that, hey, somebody else might have to take up my work later on. So we just want to keep good documentation, especially when it comes to exceptions. And so my next point with that is throwing exceptions with descriptive messages kind of falls in line with documenting. But I think to that point, I want to say when you are returning a specific response to your exception, try to be a little clear cut with it. So if I'm giving you back a stack trace, that could be over 50 to 100 lines of errors. And sometimes we as developers don't have time to look through that. Not only that, we don't necessarily know what's going on, especially if we're not the ones that developed it. So if you can, try to always send back a response that says, hey, you know, there's a foreign key constraint that's missing from here. This is what I was expecting. Please insert correct key or something of that nature, or whatever the exception may be. And this ties into the next one. Try to give specific exceptions as well, because that will also help other developers understand that, hey, I understand this is a general exception, but getting a more specific one will let people know that this is the exact problem that you're having with this business logic. And last but not least, do not use throwable. One, that it will throw errors in exceptions, and it's very general. It's more general than exceptions. So let's just avoid that altogether. So let's say you're writing a whole bunch of code, or you're inheriting a whole bunch of code from someone else. It's too much code. Exceptions could come from anywhere, but it's okay because you can actually handle that in a centralized way. So recently I've come across the fact that you can use a global exception handler. So the global exception handler class allows you to centralize your methods where you can handle any and all types of exceptions, from generic to very specific. And so here's a good example of it. I couldn't show you guys too much because then I may not have a job afterwards. So, but anyway, so this is the global exception handler class. The first thing you always want to do when making this class first is put a controller advice. This basically tells your application that, hey, any exceptions that you have, we're going to cut here first to check if you have any methods set up to handle any type of like specific exceptions. So I'm just going to walk through it real quick. Once you start your method right here where it says they handle data integrity violation exceptions, very specific. Again, it usually has to do with foreign key constraints or something revolving around data constraints in SQL. I always annotate with an exception handler. And then I typically like to send my response back up with a response entity. It works, I think it was not David, but Neil that said something earlier about returning response entities. It acts as a response body, encapsulating other types of fields that you can use. So with that, all this method is doing is that it takes in a data integrity violation exception. So anywhere inside of the code that I might have to throw a data integrity violation exception, it will automatically cut here first and figure out how I would like it to be handled. So just to walk through it, the first line here where it says string data field, this is I've made a helper method to help me, let's say, rip through or read through the error message itself and parse out a certain data field. And what I do is I'll have a blank error message, and depending upon the actual instance of it being a data integrity violation exception, I will, if it's null, I'll just tell them that, hey, you probably entered a null field. Or in this case, if the field I'm looking for is present, I will take the data field message, append it to the rest of the message, and just, like I said earlier, parent key could not be found, or so please insert a correct or pre-existing key. And then with that, I'm able to return a build, or I can build a response entity, which usually just returns a class I made up, which is an API error class. This just allows, it's just an entity class that allows me to have like the status code, the message, or like the status type. So anybody can make that. It's just a simple entity class. But I haven't built that into my response entity. So it returns an API error code, which houses, in this case, the status code, the error message, and the exception that happened. And you spit that back up to the user or yourself, whoever's looking at it. And it usually draws out a very specific message and gives the user a quicker way to handle the exception that has been thrown. And so just a quick summary. I know it's getting late, so we're about to get out of here after the last speaker, obviously. So just a quick summary. The exceptions are not to be confused with errors. Exceptions can cause your application to crash. So we want to prevent any of that to happen. Always use your try catch in your worst case scenario. There are several exceptions that can be had. So just always try to figure out what is the most specific one you can have and try to put it in place there. And when handling, like I said, always use a try catch. And whenever you think there may be too many exceptions to handle from different parts of your code, always use a global handler exception to centralize where you could use your exceptions in handling them. With that said, is there any questions? All right, cool. Well, thank you guys. My socials are here. JP Develops. You can find me on LinkedIn at Jordan Parker, and then JP Develops on Instagram. I'm more active on Twitter and LinkedIn. Thank you guys.
Thank you everyone for having me this evening. So I am replacing the speaker that was just for you that are in the, I guess, in the Zoom because of some technical difficulties. So my name is David Kia. And I am a newly minted software dev or software engineer as of 3 weeks ago. And so one of the subject areas for me as a new dev, and I'm pretty sure a lot of people, is that, or just to give a little bit about myself before I get into it. Yeah, I already did that. Let's get into Lambdas. Let's get into the presentation. Was getting to lambdas and streams. And so I tried for the life of me to avoid lambdas and streams, like, trust me, still. And so it wasn't until I just thought about it like this, like eventually I'll be confronted with them, so I might as well talk about it. And when Danny asked for me to speak about something, I literally didn't know what to talk about. And so I had this expression. Oh, am I sharing?
You're not sharing.
Oh, I'm not sharing the screen.
Go back to the Zoom call.
Okay, so now they can see it. Okay, cool. Awesome.
Now go back to that slide. Let's make sure.
Now they got it in the Zoom? Okay, cool. Okay, cool.
So I think if you switch desktops, you should be able to get back to it. Do you know how to do that?
So that should be,
No,
oh,
just do this.
is it? Oh, back to the screen.
Yeah.
Thank you. Learn something new every day. Thank you. Appreciate it. Okay, so that look right there. Thank you. But before we start, if you have your phones or if you're looking at the screen right now, please let's connect. This is my link tree. This is going to show you some links and websites that are obviously I'm on. It's going to be my Twitter, my LinkedIn, and a couple other things, but you'll get some information about me. So I'll leave that up for just a moment. And there's another one at the end of the presentation, so I'll definitely have that up again for you. Okay, so what is a Lambda expression? So for some of my folks in here, the first thing that came to mind as I was learning Java, when they said Lambda, I'm thinking Revenge of the Nerds, Lambda, 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 if you're familiar with that. And I'm like, okay, I know it's a type of symbol. What does that mean? but this is what it means in Java. An expression or a random expression is a block of code that gets passed around like an anonymous method. So now I'm sitting up here thinking to myself, what's an anonymous method? So I'm just like, okay. And then I'm like digging a little bit more. And then I see it's expressions. Lambda expressions rely on the notion of deferred execution, meaning that they're executed later. Okay, it's specified first, then executed later. So this is what I had to do when I was thinking about this. And I was like, okay, let's just breathe. Let's just see, let's relax. All right. And you can do the same as well. So here's an example of up top, a Lambda expression. And then at the bottom of it, the anonymous class that they were talking about, anonymous method. So what you see is highlighted in the yellow is going to be your Lambda parameters. Then you have the arrow, and then on the right, you have the Lambda body. So then you have the file class folder, comma, string class file name. And what it's saying here is, hey, folder, can you read what's in the folder? And can you find any file name with the last or that ends with a .pdf? But as you can see below the anonymous class, it's a little bit more code to it. And this field name filter class, filter, variable, new. So this is the method, okay? Override, now we're going into the Boolean accept, file directory, string name, return directory.canread, and name.ends with PDF. Okay. So when I first looked at that, I'm like, what is going on here? But as you can see, when you're using the Lambda expression, it actually shortens the code for you. And we're going to have some more examples so we can see that again. So what I did was I went to good old IntelliJ. And for my Eclipse folks, no disrespect, but I love IntelliJ. But I created an interface class because usually you see Lambda expressions used with an interface class. So what I wanted to do was just keep it real simple and say, okay, public interface, my interface, and then have a method that's not returning anything at the moment, just test two numbers, N1 and N2. We go to the main class. Now I'm going to call that interface class. Now all of this is kind of inferring that we're implementing interface, right? So some of these things are just inferred, but I also have references for that as well. So my interface, now I'm taking, remember on the left-hand side, we're looking at the Lambda parameters. Now I'm taking those two numbers from the interface, and now I'm saying, hey, point to what I want you to do in this body. And what I want you to do is return whether or not number one is greater than number two. And then I'm going to go out and print out at the bottom, call my interface, because we got to call the my interface. Now the test method from the interface class. And now we're looking at the basically 35, is it greater than 26? Returns true, it's a Boolean. And right underneath that, it's 23, is it greater than 100? No, that returns false. Now you might say to yourself, well, why would I want to use a Lambda class or a Lambda expression? And I kind of thought about this myself, or even in my interface. And if you wanted to just use it for something that's reoccurring a lot of times, but just one instance, such as if you're registering for the first time into a website or into an account, you don't have to register again. You can just register once. And this would be a useful instance of using an interface class. So now that we're done with Lambdas, let's get into streams, and not what they were talking about earlier with the multi-threading and concurrency, not quite yet, not there, but just the API. And if anyone is familiar with Abdul Bari Muhammad, I ended up taking some courses with him. He's an excellent instructor out of India. And he shortened what is a stream to just the flow of data. 20 plus years, and that is what he said, a flow of data. But as you can see, not so simple, right? That's the definition of a stream. But just three little kind of breakdowns of what a stream can be, what it can be used for. So as you can see, I'm not going to read this in detail, but you can see what a stream is. And if you want to screenshot that, definitely screenshot that right now. Yeah, that's how I was looking on the first page. But then guess what? There was more. And with the Stream API, what I want to show you is that you can use this to kind of do a more declarative approach to your code with underlying tones of imperative. Now you're probably saying, what is imperative, what is declarative? Because I said the same thing. Come on, what are these words? Well, think of it like this. If it's imperative programming, think of it like you go into a restaurant, you have a host, and that host takes you to your table, and they're walking through the aisles, and they get you to the table. That's imperative approach. Declarative is you walk into the restaurant and you go straight to the table. You still get to the table both ways, but one just takes a little bit more steps. So just listening to a lot of videos and hearing a lot of different developers talk about it, I've concluded that that was the best way for me to kind of understand that, was that versus imperative and declarative. And here, using streaming, you're going to see just examples of that as well, or the Stream API, I should say. So we have a main method. We're going to start out just a little light right now. And we have our string array, 1, 2, 3, 4, 5. We're going to keep it simple, right? So we're going to use the arrays class, calling stream method, and pull in that array variable and say, hey, for each, just simply print it out. And I like to keep a little space in between my code, just keep it nice and neat and clean. And as you can see at the bottom, you can see the solutions. The first solution is 1, 2, 3, 4, 5. Now, using the arrays class again, dot stream method, I'm going to say, hey, not only do I want that array variable, but I want to look for between 1 through 4. And for each and print out, you probably say, oh, that's like the same amount of code. Okay, cool. Well, we're going to get there. But this is just one way you can use the Stream API. Here's another example. In our main method, we're going to use the collections API. And then we're going to call a generic string collection, using a new hash set. And we're going to add to that collection. Then we're going to stream through those countries, have a collection, call that API or that method stream. But after that, you're just saying, okay, now, hey, stream, I want you to do something. So right after that, you have to, I wanted to sort it. And then I basically went down to the countries and I said, okay, I want to print out, go through each one of these, but I want you to sort through that using that stream API. And the solution was at the bottom. So that was just one way I wanted to test out how it worked, what it looked like, how I could use it in my code, and yet keep it simple for implementation later. So this is another way that you can use it. Now, this is the funky stuff right here. This is where we get to see it in action a little bit. Okay, so going from left to right and maybe right to left, I had to copy the code a little bit. And so on the left, I created a class up top, a enum class of male and female. And just below that, I wanted to create a list, a method type of people to return whenever I wanted to call some information for what I was going to do. On the far right, you will see where I had to create a constructor, getter methods, and a toString method. But in the middle is where the action happened. And you'll see up top, where the streams come in really effective is normally when you're using imperative approach, you're going to see what we got: the list of females, new array list, then we have our for loop and our if loop. And if anyone knows about nested loops, you already know that depending on how many iterations there are, it could take quite some time. Even though it looks like it's coming out fast, it's still 2 to 3 seconds, maybe 4 or 5. It just depends on however much data. As you're getting more and more, it can be very timely process. But let's just take a little look below. And these next 2 opportunities, we have examples of streams. And we take that same list of females, but now we can call that stream API and we can filter. Now this is declarative. We're just saying, hey, we want you to go through that list. We want you to get the gender that equals female and collect it into a list and print out that result. And as you can see, you already save a couple lines of code. And when you actually run it, it's actually a lot faster. Or it's actually faster than doing the for loop the if loop, the for loop within the if loop, or if statement, I should say. And so then there's the last example of that where I just sorted through the people and I was comparing their ages. So this is just a kind of bonus code that you can use yourself. You can kind of copy with it, play with it, and maybe you want to use it sometime later. I know I definitely will after testing it out. Any questions? Yes, sir.
One thing that I would suggest is, so I think maybe you can show them.
Oh, definitely. Okay, yeah, I could definitely do that. And then what I would like to do, oh, yes, sir. Go for it. Oh, okay, sorry about that. So this one. Oh, okay. Oh. So I know what he's saying. So the class that was omitted from here, you don't see, but it was in IntelliJ. That's why I say it was kind of inferred, where I actually implemented that interface. So that wasn't pasted and copied into it. So it was just that part. Yeah.
Just updated on.
Hold on.
If you have a single. So if you do that, as a functional. More than one method you could use.
Right.
That works really well because what they found out why they did that is many of their when they first started out. 95, yeah, maybe you weren't one minute, but it's almost like 40. We only had 20 or really well. Very fun. Well, it was guys
And thank you for the explanation. I appreciate that very much. And that does conclude the presentation. However, I do want to make sure that you get these references up here. So if you want to take a snapshot of that or a screenshot, these are some of the tools that I used. As you can see, a lot of this is either from D-Zone or some is from D-Zone. I actually love books because books are the only things that don't go out when the power goes out and the electricity is gone. So I do have quite a bit of those that I can reference and touch and feel and carry to work with me. And that's pretty much it. Thank you.
positive
Yeah, I know, right?
attitude.
We're gonna act like y'all haven't seen me up here before.
Make sure the Zoom call to unmute you.
Yep, I think I already unmuted. Yep.
Yep, perfect.
All right, and then let's make sure that I can share. And can everyone see my screen now?
Yep.
Yeah? No, it's just a slide deck. Cool. All right. Cool. Well, hello, y'all. My name is Devin Coyer. I am a senior front-end engineer at a company called LogicGate. But traditionally, my background has been in full stack engineering in Spring Boot and React and Angular. And today I wanted to share about kind of thinking about how we can build resilient and robust APIs in Spring Boot using test-driven development. And there's been a lot of emphasis on testing here tonight. I don't know if that was intentional or it just happened to line up that way. But really the reason that is because it's a very important thing. And I think for developers who are pushed up against deadlines and who are trying to complete their tasks, it can kind of be something that we're tempted to push to the wayside. And ultimately our tests become sort of a quick validation that we've looked over our code and not really something that we use to validate that our code is doing what the business owner and what the product owners wants the code to do, and that it's able to consistently perform what it needs to. So I want to talk about how we can kind of change that mindset by implementing test-driven development. So before we start then, what is test-driven development? Test-driven development is not just test before. And what I mean by that is a lot of times when you look at people who implement TDD, it's basically writing the same test that you might write after you've written your method, just doing it in reverse, right? And it falls back to just being a test that's there for the sake of having a test and making sure that my lines are covered, when in reality, I'm not actually verifying the functionality in my code and even shaping the way that my code is created through those tests. Test-driven development designs the code around the test cases and the acceptance criteria that are brought in before we even work on the code. What that means is we should be building our tests in a way that are written in a way that tracks behavior and make sure that we're honoring the business contract that we're given, the requirements and the specs that we have, and that should inform the way that we write our code, not that the code should inform our tests. TDD also optimizes the number and types of tests. What I mean by that is if you do test after or maybe more traditional unit testing, you may end up with very few tests that are very large and assert and check on multiple things. And test-driven development kind of pushes against that to say we should have very small, very specific tests that are asserting and verifying, well, very specific things. And then finally, test-driven development also provides comprehensive code and API documentation. Because they're so granular and because they're so specific, the tests written as you're following test-driven development will often serve as documentation and actual verification that if you read through those tests, you will understand what the code is doing and why under what situations. Meaning that it's not only something that's meant to ensure that your code continues to work as changes are made, but as you onboard new members and as you look back at legacy code, you should understand not only what it does, but why it does and what makes it do that. So then what kind of tests should we write? We're going to be going over two types of tests today. This is an opinionated approach, so I understand that not everyone's going to agree with the terminology, but there are two main types of tests that I would say are going to be ones that we write as developers as we're developing our code. There's going to be unit tests. Unit tests are small, very focused tests that pertain to specific function paths and deal specifically with our code. That means that they're very business logic oriented and they're not really testing anything that has to do with the framework, any HTTP, anything like that. It's just the code that we're actually writing. And because of that, it doesn't require the Spring context to be instantiated. We don't need any IOC frameworks. We're going to be creating and injecting everything manually through mocks like Mockito. And we're going to be handling all that within our tests. They're also very lightweight because they don't require the Spring context or framework. We can actually run these tests in ultra fast succession. And so we can have a wide number of them being very small and still keep our performance relatively fast when we're trying to build in a pipeline, for instance. The second type of tests are called integration tests. I'm also going to add like a hyphen there and say mock MVC tests or parenthesis rather. What I mean by this is integration tests change their definition depending on who you're talking to. Some people might consider those to be in a simulated environment, reaching a test database and different things like that. For the purposes of this talk today, we're going to be considering them to be mock MVC tests. And what that means is that we're going to write tests and we're going to run them in the context of the Spring framework with that context spun up. And we're going to still be mocking components, but we're going to simulate HTTP calls. We're going to assert on some of the response statuses, and we're going to follow that pattern. And just know that I'll be calling that integration test, even though it might be called something different in your workplace, right? So like I said, they test things like HTTP methods, response codes. They require the Spring context. But really what they are is they fill in the gaps where unit tests can't reach. Because they're very heavy and they take quite a while to run, we want to write very few of them. And because of that, we want to write these integration tests or mock MVC tests for the things that we can't test directly in unit tests, right? Again, like those HTTP statuses and such. We'll get to what that is in just a minute here. I wanted to bring this up because this is kind of a nice little visual. Are any of y'all familiar with the testing pyramid? Basically, the testing pyramid is a diagram that helps you understand the types of tests and the quantity of them that should exist in your code. At the bottom of the pyramid, we have unit tests. And the reason that they're at the bottom is because that's the widest platform and that's the base. Your application should have a wide number of unit tests. Because they're so lightweight, they can be run quickly and they can serve as the bedrock of your testing. Next up would be integration tests. This is that mock MVC test. They're heavier, they're slower, so there should be fewer and they should fill in the gaps where something like a JUnit test couldn't get to. And then finally, we have end-to-end tests. This would be something like Selenium. This would be like WebDriver. Some of the things that were spoken about here earlier tonight. These would be sort of that last gate of spinning everything together and testing the full stack. Again, anything that integration tests can't cover. So this is kind of like just a general understanding of philosophy of the types of tests and where they should be in your code. So finally, we're going to get to some coding. If you want to follow along, this is a QR code to a GitHub repo. You can clone it down if you want to. If not, that's fine. We're going to be going pretty quick since we're running short on time. So I just wanted to make that available to y'all. I'll make sure to share it with Danny as well so he can distribute it to everyone. So I am going to definitely increase the font size here. So give me just a moment on that. And let me know when the font size is kind of about right for what you'd like and is comfortable to look at here. Is that good for everyone? Perfect. All right. So let me get rid of this stuff that's in the way. All right. So what we have here is just a simple controller. What we're going to be doing today is implementing at least one method. If we have time, we'll create a second. But what we want to do is we want to create a get endpoint at a /greet route that returns the string hello world. It's very simple, right? But the goal is that we're actually going to do this using TDD. And so instead of just writing our method, we're going to be writing tests that adhere to the criteria that we've laid out here. And then we're going to implement our code around those tests. So what we're going to do is we're going to start in a simple unit test file. I've already added some of the scaffolding here, but essentially this is a test file. We have a reference to our controller class, and we have a method that runs before each test that basically reinstantiates the class as a new instance of itself. So what I'm going to want to do first is I'm going to want to start and I'm going to say, what is the simplest test that I could possibly write to validate some of the functionality of what I'm required to do in this specific spec. So for the purposes here, we're going to annotate, we're going to make an @test public void. I like to follow a given when then pattern for naming tests. So I'm going to say given a valid request when greet is called, then return string. I'd make it more. I'd make it a little bit more robust, but I'm just going to name it that for now for the sake of time. Inside our test, we're typically going to have 3 different sections. We're going to have an arrange section where we're going to set up anything like our mocks before we run our test. We're going to have an act section where we call the method under test. And then we're going to have an assert section where we actually verify that what we expect to happen happened. So for the purposes of this, what I want to do in test-driven development is write the simplest test case and make it fail first and have that failure cause me or force me to implement some amount of code to make that simple test case pass. So in this case, I'm going to say string result equals our controller dot greet. And I want to assert that that equals hello world. Now, it doesn't exist yet, so we're going to run into our first issue here, which is that our test or our class doesn't actually have that method yet. So we're going to have it generate that greet method within our controller. And to make this test fail first, we're just going to return null. I'll run my test. Oops, I forgot this. Results, hello world. Should actually be the other way around. Rerun that test. And we should see that it fails because it expected hello world, but we really got a null result. Yeah. So you'll see that we expected hello world. What we got in reality was null. So now that I have a test that's causing my code to fail, I want to do the least amount of work in order to make my code pass. So for this specific example, the fastest thing that I could do is just to have my method return hello world. Whether that's what we want it to do or not is irrelevant at this point. We just want to make our test pass and be satisfied. And if there's additional functionality that we need, then we have to write another test to cause our code to do something additional. What I'm going to do then is I'm going to say, hey, actually, I expect that the result that I get back from my controller is going to be returned from a service layer. So I expect my controller to have actually called a service and that service to have responded with what I returned in the controller endpoint. So I'm going to do another public void. Give invalid request. When greet is called, then calls service. We'll have another arrange, act, and assert section here. And this is where we'll get into our arrange a little bit. So what I'm going to want to do is I actually have a hello world service defined here with a simple greet method. Okay. What I want is for my controller to call this greet method and return whatever it sends to it, right? So whatever greet returns, my controller should send back to the caller. So in this case, then what I'm going to do is I'm going to bring in to my test class a private hello world service. And I'm going to add on to my init method here that I want to mock this out. Now in a unit test, I want to make sure that any external dependencies to my test class are effectively mocked out, meaning that instead of calling the real version of that class, I'm going to be calling a fake or a mock or a stub where I can control any interactions and verify them that come from that interacting class. So I'm going to say this.hello world service equals, I'm going to bring in mockito.mock hello world service.class. So I'm saying, hey, instead of making an actual hello world service, let's make sure that we bring in a mock instead and make that my reference. So in my arrange, then I'm going to tell that service what to do. So I'm going to say when my hello world service greet method is called, then I want you to return, and we'll make it different just for the sake of it. We'll say hello universe, and this should be in the next method down. So whenever I call the hello world service greet, I expect that mock then, instead of returning the hello world, to return hello universe in this instance. Then under my act, I'm going to call my hello world controller. And then I'm going to assert. And instead of inserting that I get anything in particular back from my controller, the first thing that I want to do is I want to verify that my controller is actually interacting with this service, since that's part of my requirement. In order to do that, I'm going to bring in a mockito.verify method. And this is going to look at the mock that I have. So I'm going to say this.hello world service, and I expect it to have called the greet method. Okay, this is going to say, hey, regardless of what happens, what's passed to it, I want to make sure that this greet method was actually called on the service. So I've written my test. I'm not going to touch my code yet. I want to run it and make it fail and force me to do something in my code. So I'll run the test. And we'll see that it fails because it expected it to have an interaction, but there were 0 interactions with the mock. Sorry, that's a little bit hard to see. So I want to make it pass now. So I'm going to go back to my controller and I'm going to say, what is the absolute simplest way? Sorry, the controller. What is the absolute simplest way that I can make this pass? And the reality is, I'm going to say, well, I need to bring in that service. So I'm going to create a reference to that hello world service. And I'm actually going to mark that as, we're not AutoWire. We'll add a constructor. And it's going to take in a hello world service. And we'll assign our service there through constructor injection. So then in our test, we're going to have to come in here and where we actually say that we're instantiating our hello world controller, we're going to pass in, instead of a real instance of that service, we're going to pass in our mock. So we're going to say, hey, I'm going to supply our class with a mock, and we're going to pass it the hello world service. So now when our controller gets instantiated, it's going to have a mock reference, and I'm going to say this dot hello world service dot greet. I'm not going to return anything from it yet because I don't have a test to verify that yet. I'm just going to satisfy the minimum requirements of this test. So I'm going to go and I'm going to run both tests. This is another important thing in test-driven development. I never want to write a test that makes me implement something that breaks another test. If I've done that, then I need to go back and refactor and make sure that all my tests are passing. In this case, both of my tests are passing because I'm calling greet and I'm still returning the hello world string there. But now I want to make sure that I'm also returning what I get from the service. And for the sake of time, I'm not going to write another test. You should. But I'm going to say that I'm going to assert equals our result. And I'm going to say expected. And I'm going to copy this over so that I don't have some loose strings here. So I'm saying it should return that. And I expect that the result I get should be equal to the string that I passed in from the service. I'm going to run it without changing any lines of code in my controller to make sure that it fails, which it does. So then the easiest way to make this pass is to return hello world service.greet. I'll run all of my tests, but if you're paying attention, you'll probably realize that one of my tests is going to fail because one of my tests hasn't told the hello world service to do anything yet. So I'll come back and I'll refactor because I broke one of my previous tests. And in this case, I'm just going to copy this over like before. And I'm going to say, and I'll set up another when statement and return that. And this one will say I should get the expected and the result. This is redundant because this is a very simple example, but I wanted to show how in implementing new functionality, you can break those older tests as you refactor because your business logic is changing. And that's expected. That's good because we want our business logic to be crafted around these unit tests. So there's one last piece that we haven't been able to test yet, and that's the fact that we want this to be a controller endpoint. I've not yet added an annotation to our controller class. I've not added an annotation to our endpoint, and therefore this isn't accessible through the internet. So what are we going to do? We're going to write an integration test or a mock MVC test, and we'll do this real quick. So to start with, in order to make this work, you're going to have to annotate your test class with a few different annotations here. We're going to extend with the Spring Extension class. We're going to mark this as a Spring Boot test, and that means that we're going to be instantiating that Spring Boot runtime and starting up that container. And then finally, the auto configure mock MVC allows us to access something called mock MVC through our tests. And mock MVC is a library that's going to allow us to do fake HTTP calls to our application and then be able to assert based on the responses from that. I don't want to go too long, so I do have a handy cheat sheet here. So I'm going to copy some things over and then we'll talk through it so that we're not taking up too much time here. So in this case, we have our integration test, and I'm going to do a mock bean on our Hello World service. In an integration test with mock MVC, I'm never going to directly instantiate anything because I expect to interact with it through quote unquote HTTP. So instead, what I'm going to do is any dependencies that I want to mock, I'm going to annotate with mock bean. And that tells the Spring Boot test that when you initialize your IOC container, put a mock in the place of this instead so that when it's auto wired in, it's auto wiring a mock instead of the real thing. I'm not doing that anymore. I'm having Spring Boot do that. Finally, I'm going to auto wire a mock MVC reference into here. And like I said before, mock MVC is going to allow us to run those fake HTTP requests to our controller. So we're going to write a test and we're going to say public void given valid requests when greet is called, then return 200 status. Notice how we're doing a little bit of a different thing here, okay? Instead of verifying anything to do with our business logic, what we're actually doing is we're verifying something that has to do with our response statuses in our HTTP. This is important because, like I said, we want our integration tests to really fill in the cracks where our unit tests can't get to, right? And in doing so, we're validating and making sure that it's doing exactly what our spec requires. So in this case, there's not really an arrange, act, and assert for this, but I'll set up at least an arrange and just when this.service.greet return hello, and we're not going to assert that because we already have an assertion for that in our unit tests. Instead, we're going to act, and we're going to say, hey, I want mock MVC perform. Oops. And the perform method is what's going to allow us to say, hey, make a request, make a fake request to our little environment that we've set up and allow me to make that HTTP request. So I'm going to say I want a get request. I'm just going to copy the import from over here. Make this a little bit quicker. Okay, so we're going to get a get, and the get takes in a string for the URL template. Oh, I'm a robot again. I'll keep going. We're going to pass in the route that we expect it to make a get request to. And in this case, under the spec, I said that I want it to be an endpoint at /greet. So I'm going to say whenever I go to /greets, and I'm going to expect the status that is okay, or in that case, a 200, because okay is 200 in HTTP status codes. Our perform method is going to have an exception that can be thrown. So we're going to say that our method here can throw an exception potentially. Oops, let's get back to here. So we're going to say, hey, this can throw an exception because the mock MVC perform can throw an exception. So what this is saying once again is that whenever I call the get with /greet, I expect to get a status 200 or okay back. All right. I'm not going to change anything in my controller yet. I want to run the test first and make it fail and force me to implement something in my test. So I'm going to go ahead and run it. And again, these are going to take a little bit longer because it is spinning up this fake Spring context for us. And we're going to say, hey, I called get and expected a 200, but in reality, I got a 404 because that doesn't exist yet. So we're going to implement that endpoint to make sure that it can actually reach it, and then we'll verify that it works appropriately. So what we're going to do is we're going to come up to our controller and we're going to annotate it with the REST controller that we saw earlier. And we're going to come down and we're going to annotate our greet with a get mapping. That's going to say, hey, make this method exposed through the get HTTP method at the route, I don't mean caps, /greet. All right. Now I'm going to run this test, and with any luck, we'll have a passing test because I forced myself to expose this over HTTP. And it passes. So if I want to go a little bit further, I can even tell it the response status and just say for verbose HTTP status .ok. It's not imported, but you can always do that. Regardless, this is just an example, very quick, very simple, of what I would consider a good way to make sure that the API endpoints and the business logic that you're implementing can be done in a test-driven pattern, where your tests are really the things informing the code that you write, and we're writing it in a way that's different than we would if we were writing our tests after. And that should ultimately make sure that we're documenting, we're testing, we're verifying, we're able to run everything, and we're adding a layer of security to our applications that frankly we just wouldn't get to or wouldn't be able to do if we tested after. I don't have a slide for questions, but if there's any questions. So arrange is a section in our unit test that's typically assigned to setting up anything that I need to happen before I call the method that I'm testing, whether that's telling a mock how to behave, whether that's setting up some data like a mock list that I'm going to pass or anything like that. I'm going to set that up in the arrange section so that by the time I call the method that I'm testing, I have everything in order and can actually do the assertions directly after that. What is the what? Sorry. Yes, so what this does is, so the question is, what is the arrange and specifically like the when and then return due? In this case, what this is doing is it's saying, hey, I have something called service, and service is an instance of my Hello World service class. Here it has a method called greet. And what we're saying is, hey, instead of calling the real thing, because in the real world, my service could be doing anything. It could be making an API call to a separate service. It could be making a database request. We don't want that to happen. We want to be able to control what's happening. So we use Mockito to say, hey, I'm going to mock this out. And whenever this method's called, instead of doing that, return this value that I want you to return instead. And that allows me to set that up so that I can assert that I'm interacting and I'm dealing with that data properly. Does that answer your question? Perfect. Anyone else? All right. Oh. Yeah, so when we use the verify method is what you're asking, like Mockito verify. Okay, so actually in our, if this would get out of my way. All right, so in our controller test, we actually do have a verify here. And Mockito verify is a method that allows us to look at a method that exists on our mock and make sure that we interacted with it properly. In this case, I did something very simple, which is make sure that I was interacted with it all. But there are ways to actually say, make sure that I interacted with it specifically one time. Make sure that I called it with a specific parameter and that it returned a specific thing. So verify is less about asserting on what my method under test did and more that it was interacting with my mocks appropriately and handling the data that it was passing to them, the number of times it interacted. It allows us to track all that and assert based off of that. Does that make sense? Does that answer your question? Anyone else have any questions, chat, people? All right. Well, then thank you for your time. My laptop thing. You want me to leave it here so you can talk? Okay, perfect.
Perfect. Thank you so much for hanging out. I will say one really interesting tidbit that I saw in that talk, leave it to a Java developer to come up with a function name so long it doesn't even fit on this big screen. Thought that was really interesting. Overall, I had a great time. Thank you all for being here. A couple of shout outs I want to make. Number one, as a reminder, because I already saw the DMs in Discord, the cohorts, you have until the end of the day tomorrow to sign up. So if that's something you want to do, highly recommend doing that. For those that have asked, if you're in the Discord, there's a news channel. It's the very first post that you're going to see in that news channel, and you can fill out the form to sign up and be considered for the cohorts. The cost of those meetups again that are coming up in the next week and a half, highly recommend checking those out. I want to give a huge shout out again to number one, Vaco. The fact that you're still here, incredible. I just want to throw that out there. Really cares about the community, you know, stuck out here this whole time. The second call I want to make is to Yum Brands, right? They donated this space for us, so thank you so much for having us. If you want to speak to Vaco, highly recommend hooking up with Eric after this. We'll have this space for like another 20 minutes because, you know, we did go way over time. So we got about 20 more minutes in this space and then we'll wrap up. One thing that we do at the very end of every single meetup that we do is we all just kind of line up over here and we take like a big group photo. I want to invite anybody online. If you want to show your video, you can be included in the group photo and we'll put you on the big screen right behind us. So if you feel comfortable doing that, you can go ahead and show turn your cameras on and we'll be right there. We're going to take a group photo and then we're going to call it at the end of this meetup. All right, so if everybody can just come over here, we'll take a group photo and then we can all like network and get together and all that good stuff. If anybody online wants to do that, you can turn your cameras on and we can have you in the photo with us. Otherwise, there's no compulsion to do so. All right. We're getting everybody lined up. Oh, I just realized my camera died. We went so long that my camera died. Okay, that explains. I was like, what happened to the view of the stage? But there that went. We're getting everybody on. I see all y'all popping up on the big screen. So, Jesse, I see you. Is that Jesse Sound? Yeah, Jesse. All right, we're gonna grab this photo together with everybody. I'll let you know once the photo is done online. Ready, 3, 2, 1. Everybody, thank you so much. We got the photos and you're in it. All right, y'all. I'll see you on the next one. Hopefully we'll connect online. See y'all. Bye.